All right, now we're on to quadratic inequalities with two variables. You'll notice that we didn't all do quadratic inequalities with one variable. That was an option for those who wanted to do it. That's because it's significantly different from how we treat linears. Linears are very easy with a one variable inequality. Quadratics, trigonometric functions, anything else adds one more layer of difficulty to it, and we just don't have the time to treat those new ideas. All right, what we can do though is we can look at quadratic inequalities with two variables. The reason why is because it's exactly like quadratic inequalities with one variable, which is what you did right before our quiz. Now, you'll remember that with a linear, what you did was you drew the line and then decided whether it was solid or dashed based off of the inequality, and then you tested a point and you shaded either above or below the line. Okay, well, that's the same thing that happens here with quadratic inequalities. The only difference is that graphing the line will be graphing a quadratic instead of a linear. So let's jump right into it. So for the moment, we're going to just pretend that this is an equal sign. So y equals x squared minus 2x minus 8. Now remember, the first thing we're going to do is look for the axis of symmetry. And when I get the axis of symmetry, that will be at x equals negative b over 2a. Now it's important that you write the x equals. Some of you still aren't writing the x equals. This is to remind you that negative b over 2a gives you a line at x equals this number. It's also to remind you that that is the x value of the vertex. If you don't write the x equals, you might forget that, and you might forget that you have to plug it back in to get y. So just write it down. It's not going to hurt you. It's just going to take an extra half a second to write x equals. So then I've got negative b, which is negative 2, over 2 times a, which is the number in front of the x squared, which is 1. Negative 2 is 2 over 2, which is 1. So my axis of symmetry is at x equals 1. I'll go ahead and draw that in. That's not part of the graph, so it's just showing me that that's where the center is. Now to get the vertex, I go vertex at x equals 1. So I put 1 back into the function, so y equals 1 squared minus 2 times 1 minus 8. So I get 1 minus 2 minus 8, which is negative 9. So I go to negative 9 and I put that point down. Alright, so there we go. I got my vertex at 1 comma negative 9. Now let's get the y-intercept. The y-intercept comes when x equals 0. So if I put 0 in for x squared, 0 in for x, I get y equals negative 8. There we go. So I put down my negative 8 right there. And then I reflect it over to the other side because I can. That's the beauty of the axis of symmetry, is that I can do those kind of things. And then the last thing that would be helpful would be the x-intercepts. Okay? So to get the x-intercepts, I'm going to make y equal to 0. So I'm going to put 0 in here. I'm still just dealing with the equation because I'm trying to get that boundary line. So I go 0 equals x squared minus 2x minus 8. We recognize that this is a quadratic, therefore we have to solve either by factoring or by doing the quadratic formula. I like factoring, so I'm going to break it up into x and x. The sign here is negative, which means this has to be a positive and a negative. I need two numbers that multiply to give me 8, which could either be 1 and 8 or 2 and 4. I'm going to go ahead and try 2 and 4. And then to make sure, because I did make a guess, it was either 1, 8 or 2, 4, I got to make sure to get the negative 2. So I check x times negative 4, which is negative 4x. And then 2 times x, which is plus 2x. I put those two together. And I get a negative 2x. So that checks out. This is the correct factorization. I don't stop here because I have two things that multiply together to give me 0, which either means that x plus 2 equals 0 or x minus 4 equals 0. That'll give me x equals negative 2 and x equals 4. Alright, so those are my x-intercepts. That was when y is 0, so I go to negative 2. And then I go to 4. Note that they're the same distance away from the center, so that's a pretty good sign. So now I've got the points. I think back to my linears, and when the inequality was less than or greater than, without the little line underneath, without the equals, then it was a dashed line. Remember, the dashed line is to represent the fact that this is our division line between the solutions and the not solutions, but that the numbers on the line don't count as solutions. All right? So we go ahead and something like this. We got our dashed line, which will go like this. If you want a little better, you can get 1 more, 2 more points in there. But I think you'll get the basic idea by now of what the quadratic should look like. So that's the quadratic. That would be the equals. However, now I need to show that y is greater than such and such. And so what I'm going to do is the same thing I did with linears, which is I'm going to test a point. So my favorite point to test is 0, 0, because that's really easy. So I'm going to put in 0, 0, which means I'm going to have 0 is greater than 0 squared minus 2x minus 2 times 0 minus 8, which means 0 is greater than negative 8. That is a true statement, which means that the point that I tested is in the shaded region, because that point is true. It makes the statement work. And because it makes the statement work, that's where I'm shading. I'm shading all of the points that make this function work. That means I could pick any point out of this shaded area and put it in this inequality, and it would result in a true statement. That's all there is to quadratic inequalities. If you've practiced your quadratic graphing and you can graph quadratic graphs and you practice the linear inequalities, this is really nothing new. It's just adding this idea to something that you've done before. Adding 2 ideas that you've done before to each other, resulting in our quadratic inequalities. All right? So that's all you got for now. Go ahead and watch a couple of other videos, because I'm going to go through a couple of other practice examples. Done.